Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a problem on resistance in smooth pipes. So the question is given here: a smooth pipe of diameter 400 millimeter, length 800 meter, carries water at the rate of 0.04 meter cube per second. Determine the head loss due to friction, wall shear stress, center line velocity, thickness of laminar layer, and consider that the kinematic viscosity of water is 0.018 stokes. So many things we need to calculate here. First, let's see what are the data is given here. As usual, we can write the data given. We can write here. First one, let's write the diameter is given. This is 400 millimeter. So this one we can convert into meter. So we can write 0.4 meter. And this one also, if we want to convert in terms of radius, we can write this r equal to 0.2 meter. Again, the length value is given 800 meter, and it carries water at the rate of 0.04 meter cube per second. That is nothing but discharge of the water or flow rate of water, you can say. So that can be indicated by Q of writing Q equal to 0.04 meter cube per second. And the kinematic viscosity, that is nu, we can write, and nu we can write in terms of this 0.018 stokes. Okay, and here Q, as usual, it can keep it like this, but this nu we can convert into, this is in terms of meter square per second, we can convert this. So let convert this one to 0.018, and that we can write 10 to the power 4 minus 4 actually. We need to first convert into centimeter square, like this stoke equal to, same we can write centimeter square per second. The centimeter square will be again minus 4 will come. So this one we can write meter square per second. Now again, we just need to calculate all these things, head loss due to the friction. So first of all, let me write here what is the head loss formula. As per the Darcy-Weber's equation, or head loss due to the friction, we know that HF equal to this is 4FL V square by 2 dg. So this is the formula here. So to calculate this one, first let's see what are the data are not given in this. So we need to calculate that one. So 4F, F is the friction factor, which is not given in this, and L length is given, V is the velocity, D value given, diameter given, G value is known. So V you need to calculate and F you need to calculate. So V is nothing but, here we need to consider the average velocity which is flowing in the pipe. So first of all, we will calculate the average velocity U, that is nothing but Q by area. So Q value is given 0.04 divided by, this is pi by 4 d square. So d is nothing but 0.4 square. So this one we can write, we can calculate this in terms of some value. That means 0.04 into this 4, denominator 4 we can take it to up. So this one, and divided by, we can do divided into pi, again divided this 0.4, again 0.4. So this is nothing but 0.318, we'll get 0.318 meter per second. This is the average velocity value. So velocity you got. Now next thing, we need to calculate the friction factor. To find out the friction factor, first we need to identify whether the flow is turbulent or laminar. So for that, we know that RE, Reynolds number equal to, we can write rho V d by mu or V d by nu. So V we have calculated just now, the average velocity need to be taken. So that is 0.318 into diameter 0.4, nu value is already there, that is 0.018 into 10 to the power minus 4. So this minus 4 we can take it to the numerator side, so it will be at a plus 4. So remaining things we can do it here. This 0.318 multiply 0.4, so divided by 0.018, so 7.073 into this 10 to the power minus 4. Let's take it to the numerator side, so it will be 10 to the power 4. So this is the value of Reynolds number, which indicates that the flow is turbulent. Okay, now for turbulent flow we have the formula of friction factor F. So F equal to, here we know the formula, 0.079 divided by, with respect to Re, that is there, that is 1 by 4. So this one we can write 0.079 and divided by this value Re, this value is 7.073 into 10 to the power 4 to the power 1 by 4. So we need to calculate this value. So what we'll do, this, okay, now we'll do one thing, 0.709 and divided by, okay, first we'll do one thing, first we'll solve this one, then we'll go for that. So this is nothing but 7.073, so we into 10 to the 4, so we will write 70730 to the power we'll write, this is 1 by 4, so 1 by 4 we can write 0.25, so we'll get 0.004. Okay, no, already we have written that one, that's why it came wrong. 70730 to the power 0.25, yeah, 16.30. So that we can write 0.073 divided by 16.30. So again, just we'll do one thing, 0.073 divided by 16.30, that will get 0.0044. So let's write here 0.004, 0.45 we can write. Okay, so this is about the friction factor value. Now we got all this value here, so just put the value in this and we'll get the value of head lost. So 0.0045 into length, how much is given, 800, and what about the value, velocity, so this one 0.318 square and divided by here 2 into diameter is 0.4 meter and into g value is 9.81. So all this value is given to us. Now again we need to just calculate this value. So this is already we have taken 0.045 into 4 into 800 into 0.318 into 0.318. So okay, now divided by, bracket start, let 2 into 0.4 into 9.81, bracket close, let complete it. So 0.184. So this is the value of head loss. So 0.184 is nothing but we can write near about 0.2 meter. Exactly we are getting actually 0.184 meter. So that one I have written in terms of 0.2 meter. This is the head lost due to the friction. Now second one is the nothing but we need to find out the wall shear stress. So wall shear stress is nothing but tau naught. So tau naught equal to, we can write, this is F rho V square by 2. Okay, F rho V square by 2. So here F value we got already calculated here, 0.0045. So 0.0045. Any one value will be get slightly different or some less value, then all this answer will be fluctuates. So carefully you need to calculate this. So this rho is nothing but the density of your water, and into V value, velocity value is there, so that is nothing but 0.318 square and divided by 2. So all these things again we need to calculate here. So 0.018 is not required for us. Now what we'll do, 0.0045 multiply 1000 into again 0.318 into 0.318, that divided by 2. So we'll get 0.2275. So this one 0.2275 Newton per meter square. Finally it will be there. Now third point, what you need to calculate, we need to calculate the center line velocity. Center line velocity is nothing but U max, because in the center line of the pipe only we will get the maximum velocity of the fluid flow. So center line velocity is nothing but U max. So when will you get the umax? Now when u will be umax, at that point your y will be r. That means the value of y equal to r, radius of the pipe. So for that also we know the formula. We can write u by u star. So in terms of u, I am writing u max. So u by u star equal to 5.75, and this is log 10, and u star again, it was u was is there sorry, u star by u star r by nu. Here u star y by nu was there, so I'm putting the value of in place of y equal to r, and this is 5.55. So this is the formula to calculate the value of u star, because u star is required in the next step. So what we'll do, we'll go for the next step. Again, what I can write here, the value of u max, what is the value of u max is here, that need to be calculated. So u max will be there. Now the value of u star, what we can see here, the u star value is not given. So again we need to find out the u star. U star equal to, the formula is nothing but tau by rho, tau naught by rho. So tau naught we have calculated just now. This is the value 0.2275. So this is nothing but 0.2275 divided by rho. Rho is nothing but 1000. So root over of this. So this one also we can calculate here. What I'll do, I'll just write point, 0.0002275 root over of this. So 0.015. So 0151 we can write. So this is 0.0151 meter per second. So this is u star. U star is nothing but the shear velocity. So this value we will put it here, 0.0151 equal to 5.75 as per our formula. This is log 10, and u star value, again we will put the value of u star, what we got here, that is 0.015 and divided by nu, and r is there, into r. R value how much? R value is nothing but radius. Radius is already we have taken diameter of 0.4 given, so r equal to 0.2. So here this is 0.2, and new value is already given in the question, that is 0.018 into 10 to the power minus 4, plus we can write 5.55. This is the formula. Now again we need to solve this one so that we can find out the value of u max here. Now u max equal to u max by 0.0151, this one, and we'll solve first this side. So what we need to do here, we'll just calculate this value, 0.0151 into 0.2, and this divided by 0.018. Okay, 0.167, this much is there, into 10 to the power minus 4 in the denominator, take it to the above. So again this one multiply 1 4 zeros, so you'll get 1677.7. So now a log of this, so 3.22 into 5.75, 18.54. So 18.54 plus 5.55, 24. So we are getting 24.09. So this is nothing but we can write 24.09, the value of u max by this one. So again, if our motto is to calculate the u max value, so just write down the u max equal to 24.09 into 0.0151. So now again this multiply with 0.0151, 0.363. So this is nothing but 0.363 meter per second. So this is the maximum velocity in the fluid flow. Now the next term is what we need to calculate, thickness of the laminar sublayer. So thickness of the laminar sublayer is nothing but delta star. We know that delta star is the laminar thickness of the laminar sublayer. And what is the formula for this? For this also one formula is there, 11.6 nu divided by u star. So what is the value of this nu value already given? So that is nothing but 0.018 into 10 to the power minus 4 and divided by u star. U star value we have calculated 0.0151. So let's solve it again. So this is not required. 11.6 into 0.018 divided by 0.0151, 13.82 divided by 1000, yeah, 0.00138, 0.00138. That is the delta star value. Delta dash is nothing but the laminar sublayer thickness. So this one is given in terms of meter. That one also we can convert into centimeter also if you want to write. Sorry, millimeter also you can convert, because most of the values we have given in the initial diameter also given in the millimeter. So let write in the terms of millimeter. We can write this is 1.38 millimeter. So this is the value of laminar sublayer thickness of the laminar sublayer. So I hope you understand this problem. So what are the things you can see we need to calculate here? Most of the questions is to ask like this kind of question, minimum 6 to 8 mark question. So head loss, this is one part. Head loss need to be calculated by using this formula. So this is one part. Next is wall shear thickness. Wall shear thickness is nothing but, wall shear stress, that is tau naught. So this formula is tau naught formula. And thickness of laminar sublayer, center line velocity. Center line velocity is nothing but U max. U max need to be calculated. So from this formula only we can calculate the U max. This formula is used for the smooth pipe. Okay, when the flow is there in the smooth pipe, so this formula was used for this. And center line velocity is because we know that if this is the pipe is there, so maximum velocity we can get it here, as I already discussed in the previously. Our velocity profile will be like this, so maximum we can get the velocity to the center line. That's why it is asked to center line velocity. We need to use this formula to find out. Now here U star is there. U star again, we don't know the U star formula. So for again U star, we need, the value was not given. So by using this U star formula, we can calculate. So I hope you understand. If you are having any doubt regarding this, you can give a comment on the comment box. Thank you all.